I'm Nima Gard, Director of AI at Path Robotics. At Path, we're working on building foundational models for manufacturing tasks. And the first model that we are building is for welding. These transformations and ingredients are providing a great opportunity for robot learning to come in and automate some of the tasks that haven't been automated for over a century. But the other aspect that is very important to foundational model is the way that they're trained. If during training we still rely on human expertise, then we haven't solved the problem. So the way that we handle this at Path Robotics is by using unsupervised learning techniques so that we don't rely on human expertise. But another key ingredient for training Obsidian is the device that we use for collecting data. Our scanners are built in-house so that we can capture data prior to welding, during welding, and after welding. And these are three different states that are very important to our training. When we get data from the fleet, it doesn't matter which customer side the data is coming from. It doesn't matter what part the data is coming from. We've removed human expertise and human annotation out of the loop. That means our models are getting better and better over time. The data comes in, good data, bad data, from good welds to bad welds, they're all good data for us. And that's how our models get better, by training on every single data point that is coming in. There are still many manufacturing steps that are waiting to be automated. We happened to start with welding because we felt like that there was a crisis approaching us. We've been collecting data for welding, but we've also developed several foundational technologies that can be applied to many other tasks. For instance, our scanner is a general purpose scanning device that can scan shiny materials. It sees through bright light, and we can inspect materials and welds after we are done with the task. We've also built methods to move robots in synchronization that can be used for other tasks. They don't necessarily have to be used for welding only. Another thing that we've done is building models for our visual data. This visual data, for instance, understanding the scene or understanding the part, can be used for other tasks. It doesn't have to be for welding. But most importantly is the strategy that we've taken to build these models and the infrastructure required to train and deploy the models. So the best practices that we've learned throughout welding automation can be applied to many other manufacturing tasks. So to build a data flywheel, there are several approaches that one can take. One, you can build a device and roll that out to the fleet. Very similar to how AV companies build a car and sell that to the public. What we've done instead, we have found a slice of a problem that is very important to our manufacturers. And when we started Path, we decided to build some models that are classical, but solve a lot of problems for our users, and start collecting data that way so that we can unify these methods together.